A seed sprouts. The roots pull minerals from the earth, leaves catch sunlight, and water pushes up the stem. It operates as a continuous event. But watch how traditional schooling fractures this picture. The leaves get assigned to biology. The sunlight is handed off to chemistry. The water pressure becomes a physics problem. And the soil? That gets filed under earth science. The tree, of course, does not care about our filing systems. Out in the real world, the soil chemistry dictates the biological growth, which depends entirely on physical water transport. The disciplines are tangled together. When we force students to look at nature exclusively through isolated categories, we hide the actual mechanics of how the universe operates. We strip away the context required to actually discover something new. For decades, education relied on a strictly content-based model. You learned a discrete list of biology facts at 9 a.m. and a completely separate list of physics formulas at 10 a.m. The focus was on retaining isolated pieces of information long enough to recall them on demand. The broader, interconnected picture simply wasn't on the syllabus. The result is a system effective at producing students who can pass standardized tests, but who struggle to combine ideas from different fields when faced with an unfamiliar challenge. Compare that rigid framework to a global logistics collapse or a sudden shift in atmospheric weather patterns. These are deeply overlapping systems. If we want to graduate people capable of navigating and solving these modern crises, the underlying architecture of how we teach has to adapt. In India, that structural pivot is mapped out in the National Education Policy 2020. The explicit directive here is a move from teaching isolated content to building actual competencies. The focus shifts from what a student can recite to how a student can think. In the middle school years, this takes the form of an integrated science curriculum. The walls dividing physics, chemistry, and biology are deliberately torn down. The objective is to train the brain early on to see overlapping networks of information. This is exactly the cognitive framework required at the highest levels of scientific research. But a policy document is just a set of instructions. To turn those goals into actual classroom practice, the teachers need a new physical tool to drive the daily work. This is the new Grade 6 textbook, Curiosity, or Kutuhala. It is engineered from the ground up for this integrated approach. The first thing it does is remove the threat of failure. The opening chapters are non-evaluative. There are no quizzes at the end of the first lesson, encouraging students to explore without the pressure of a grade. Second, the book weaves cultural and historical context directly into the hard data. By incorporating themes like Indian knowledge systems, the science stops floating in a vacuum and anchors itself to human history. Third, passive reading is largely replaced. The material demands hands-on, peer-based activities, forcing students to negotiate, puzzle solve, and physically interact with the concepts. This schematic shows how the physical page acts as a gateway. Integrated QR codes pull students out of the printed text and into a broader digital ecosystem of documentaries, audio, and interactive models. The design forces a shift in behavior. The student goes from sitting passively and receiving instructions to actively doing the work of a scientist. In an integrated classroom, the dynamic of asking questions inverts. A question is no longer a trap set by a teacher to test memory. It becomes a tool the student uses to pull apart a concept. The motivation moves away from trying to guess the right answer and toward a genuine drive to figure out how a mechanism actually operates. As the Kannada introduction to the textbook points out, this is the very definition of science. It is a continuous method of observing the world, thinking critically, and acting to uncover the mysteries of the universe. That specific trait, a relentless drive to figure out how disparate parts connect, is the exact engine behind our most advanced observatories and laboratories. When we design classrooms that mirror the interconnected reality of the universe, we give students the analytical tools they need to make sense of it. We stop handing them a disconnected list of facts about the world as we currently understand it, and finally give them the skills to discover what it could be tomorrow.